Welcome to the DataStax Astra DB course. In this course, we will start with the discussion about the DataStax as a company. We will review the products offered by DataStax. We will understand what is Astra DB. We will discuss why Astra DB is an important technology. We will sign up for a free Astra DB account, and there is no need to provide a credit card or any other kind of payment. We will then log into the Astra DB portal. We will take a quick look at organizations and their settings. We will understand what is provided on Astra DB portal. We will discuss about change data capture and Astra streaming service. We will understand where to find documentation and how to use Help Center. We will create our first Astra DB. We will learn how to check our Astra database details, usage for current billing period, and cloud regions. We will discuss about some of the options available under premium service. We will learn how to terminate the database. We will launch and use the Cassandra query language shell or the console. We will create a new key space. We will create a table and populate some sample data. We will learn about all the supported options available to connect from the application to the Astra DB. We will learn about Python Cassandra driver. We will install and configure Python Cassandra driver in a Linux virtual machine. We will download pre-existing Python code from a GitHub repository and configure it to connect to our Astra DB. We will run the Python program to retrieve Astra DB cluster information. We will configure and run the pre-existing Python code to generate sales data which will be stored in our Astra DB. We will learn how to generate the sales data automatically using the cron tab in Linux. We will check the Astra database health and also verify the pre-integrated Grafana charts. We will conclude this course with learning about hibernated state of Astra DB, and we will learn how to resume the hibernated database. I am very excited to guide you through this learning path for DataStax Astra DB. Prerequisites for this course. You need to know what is Apache Cassandra. You should have basic knowledge of how to use Apache Cassandra. You should have prior knowledge of the Linux operating system. Prior knowledge of Python programming language will be very helpful. Note that we will not learn about Apache Cassandra or Linux operating system or Python programming in this course. With that said, let us get started with this exciting journey of DataStax Astra DB. Let us now spend a few minutes to understand the role of DataStax in the Cassandra ecosystem. DataStax is the real-time data company. They help enterprises mobilize real-time data and quickly build smart, highly scalable applications required to become data-driven businesses. The DataStax Astra Cloud Service uniquely delivers the power of Apache Cassandra, the world's most scalable database, with the advanced Apache Pulsar streaming technology in a unified stack available on any cloud. DataStax offers several products. Astra DB is a serverless database which can run on multi-cloud, and it is built on world's most scalable database, Apache Cassandra. Astra Streaming is a multi-cloud streaming service built on Apache Pulsar. DataStax Enterprise is a very scalable enterprise-ready database including security, analytics, search, and graph support. Under Luna support, organizations can sign up for 24/7 technical support for open source Apache Cassandra and Apache Pulsar. Many employees who work at DataStax are heavily involved and contribute to the open source project of Apache Cassandra. Stargate is an open source data gateway that sits between your application and your databases. Cassandra is a production-ready platform for running Apache Cassandra on Kubernetes. DataStax provides a lot of resources for the developers, and you can find them on this web page. DataStax also conducts several hands-on workshops on weekly basis. You can find out details about these workshops on this web page. The video recording of all the past workshops are available via DataStax developers YouTube channel. If you want to learn Apache Cassandra and related technologies using structured learning courses and then get certified on these technologies, then go to DataStax Academy website. You will find a lot of resources for free on the DataStax Academy website. Hope this provided some information to understand the role of DataStax in the Cassandra ecosystem. Let us now spend few minutes to understand what is Astra DB and why it is important for the Cassandra ecosystem. Apache Cassandra was first made available to public during 2009. From a very long time, Apache Cassandra is highly scalable. It supported multi-data center configuration, and it is highly available even when the nodes from the same cluster are distributed across geographical locations. Over the past 10 years, many companies have deployed Apache Cassandra on physical hardware as well as virtual servers. Many companies such as Netflix have been running Cassandra on cloud for a very long time. Apache Cassandra project reached a major milestone during 2020 when DataStax released Cassandra as an open source project. Cassandra is a production-ready platform for running Apache Cassandra on Kubernetes. DataStax achieved another major milestone in 2020 by introducing DataStax Astra DB to the Cassandra community. Astra DB was introduced to the world as database as a service for Cassandra applications, which can run in a multi-cloud configuration. In 2021, DataStax announced a serverless version of Astra DB along with pay-as-you-go model for developing Cassandra applications natively on cloud. DataStax Astra DB is a cloud database service based on Apache Cassandra. Between 2021 and 2022, DataStax introduced Astra Streaming as a service. Astra Streaming is a messaging and event streaming cloud service based on Apache Pulsar. In 2022, DataStax introduced a stronger integration between Astra DB and Astra Streaming. They introduced change data capture capability for Astra DB, and the changed data can be natively streamed to Astra Streaming service. By end of 2022, DataStax Astra DB with Astra Streaming service is available to run on cloud providers such as Amazon Web Services and Google Cloud vendors. And Astra is fully managed by DataStax as a serverless service. As you can see, DataStax Astra DB is most important milestone for the Apache Cassandra project. Let us now register for an Astra DB account. First, let us go to the DataStax website. Under products, we will see a link to Astra DB webpage. This is the home page for Astra DB. We can click on Register Now button to get to the registration page. This is the registration page for DataStax Astra DB. This is a very easy registration process. We just have to provide our first name, last name, work email address, and a password to create the DataStax Astra DB account. Note that we don't have to provide any credit card details for registering for Astra DB. We can also use our pre-existing Google account or a GitHub account to register for Astra DB. In this case, I will just use my pre-existing Google account to register for an Astra DB account. I will just select a pre-existing Google account for signing up for Astra DB. I will provide my Google password to sign in. As you can see here, on this web page, DataStax has provided links to the terms and policies to use DataStax Astra DB services. I will now accept the DataStax terms and policies. On this page, we have to provide few more details. As you can see, I have just selected options which are suitable for myself. You can select different options which are suitable for you. I will click on the Finish Sign Up button. As you can see here, Astra DB portal is now showing a Getting Started page. I will close this window. By the way, this Gmail ID is not a valid one. Please do not send any emails. Welcome to the Astra DB portal. First thing I want to show you is how to properly log out from the Astra DB portal. Let's go here and click on Logout. So now that we have successfully created a new Astra DB account, we can go to this web page and sign into the Astra DB portal. You can use your Astra DB credentials to sign in. In my case, I will use my Google account to sign in. We have successfully logged back into the Astra DB portal. During November 2022, DataStax has introduced a new user interface for this portal. What you see here is an old user interface. So now I'll show you how to enable or disable the new user interface. We can enable the new user interface by clicking on this button. As you can see here, this is the welcome page for the new user interface. Now, if you want to disable the new user interface, we can go to this button here, which is the account button, and you will see a disable new user interface option. Note that this menu also has an option to log out from this portal. Now, Let me quickly disable the new user interface and show you what happens when we do that. As you can see here, DataStax is asking for a feedback on trying the new user interface. I'm going to ignore this and click on no thanks for now. For the rest of this course, I will use the new user interface. So remember that DataStax is continuously making changes to Astra DB and improving it on daily basis. In few months from now, your user interface might look like this, or it can change in future. But for now, we will continue to use this new user interface for rest of our course. Let us now discuss about organizations. Imagine you have different departments such as marketing department, sales department, and returns department in your company. And you want to maintain a separate database for each department. We can achieve this by using organizations option. By default, Astra DB portal will create one organization with our email ID. We will now go to Manage Organizations page. As you can see here, this is the default organization and it was created with our email ID. Let us now add a new organization. Note that both organization name and organization email ID are required. Again, note that this is not a valid email ID. Please do not send any emails. Let us now create this organization by clicking on Add button. We have successfully added a sales organization. We will discuss about user management a little later. As you can see here, currently we do not have any active databases, meaning we haven't created any databases yet. By clicking on these three dots, we can get a pop-down menu and it has two options: to switch organization and to delete an organization. And note that we cannot delete a default organization which was created by Astra DB portal using our email ID. I want to switch to the newly created sales organization. I generally switch organizations using a different option. Let me show you that. Whenever I want to switch organizations, I generally use this menu. Let's now switch to the sales organization. As you can see here, I have now switched to the sales organization. We can click on the settings option to verify and modify the settings for organizations. We will take a look at user management, role management, and token management a little later. Let us now take a look at the billing options for the organization. Notice that we are currently using a free subscription for Astra DB. After we create a database, we can come back and revisit this page. Let us now take a look at the security settings for sales organization. As you can see here, key encryption is only available under Astra DB's premium service. Single sign-on authentication using an identity provider can be configured using this option. Audit logs contain historical changes made to the user accounts and roles. We can download the audit logs using this option. I hope that was a good introduction to organizations in DataStax Astra DB. Note that at any given time, we can go back to the home page by clicking on this Home button. As you know, we are currently using a free plan for DataStax Astra DB. We can upgrade to the paid version by visiting this page. I will now continue to use the free version. So let me cancel this and go back to the home page. While learning any new software, it is very important to know how to get help or how to find documentation about the product. By clicking on this Help button, we can go to the Help Center. Help Center contains all the required steps to use Astra DB documented in an easy to understand fashion. Let me also show you a link to the documentation. So if you scroll down on this list, you will see the documentation link right there. This is the DataStax documentation homepage. We can find Astra DB under this list, and this is the DataStax Astra DB documentation page. This is very helpful if you want to learn about Astra DB in deep. Also, do not forget to check out the Get Started section on the home page. Okay, let's go create our first Astra database. We'll create a database for sales organization. So I will click on this databases option, and then I can click on a create database option here. So far we have not created any databases for sales organization. We are going to use the free plan available for Astra DB. As you can see here, I want to name my database as Auramad, and the key space name I have provided is Astra_demo. As you know, Astra DB supports multiple cloud vendors. Let us go through what Google Cloud provides. I'm going to check what is available under North America. As you can see here, all the regions available for Google Cloud under North America are listed here. Under the free Astra DB tier, we have access to only one region. All these regions which have lock symbol on it are under paid services. I'm going to select the region which is available for me as a free region. When you log in, you might see different options for your region available as free. Let us now quickly review if we have any options for Europe, Middle East, or Asia Pacific. As you see here, this is the free available region in Europe. We also have one free region available in Asia. As you can see, we have a lot of choice for Amazon Web Services also. For now, I'm going to go and use Google Cloud, North America, and select the free region available. All the remaining regions are locked out right now and they are not available for free. Let's go ahead and create the database now by clicking on the Create Database button. As you can see here, database has been created and it is doing some more remaining tasks like pending token generation and the key space creation. In about 45 seconds or less than 1 minute, we will have our database ready with the first key space available to use. As you can see here, our database is now active. Let's go to the databases page. And this is the overview, or you can call it as a dashboard for the databases. This is our database name. As you can see here, we have not yet started using this database, so all these metrics are set to 0. Our database is running in this Google Cloud North America region. If we pay for this service, we can select other regions where we can make our database run in a high available fashion, and it supports multi-cloud vendors. Meaning you can have few nodes running in the Google Cloud in North America region and few other nodes running in a different region under AWS for the same database. If we scroll down here, the initial key space we created is listed here. In future, we can use this add key space option to create new key spaces. I want you to notice one other thing here. Every time we go to the dashboard for databases, I want to check the database status. Right now, database status is active. Let us now go to the settings tab for this database. As you can see here, private endpoints option is available under the premium service for the Astra DB. Currently, our database is not restricted. We can use the IP access list to restrict the public access from internet. For this course, I'm not going to use this option. I'm not going to restrict anything, and we just use the database without any restrictions. As you can see here, export metrics option is also available only under premium service of Astra DB. If you ever want to terminate the database, meaning you want to drop the database, here is the option to terminate the database. Now let's go ahead and talk about the Cassandra query language console to connect to our Astra DB and check our key spaces and the tables. We can click on the CQL Console option over here. As you can see, CQL Console is little bit small in size. So let me show you how I set it up to increase the size of the font and the work area. I'm going to first collapse this left side menu. I'm going to remove this notification to disable the new user interface. On the keyboard, I can press Ctrl plus to increase the size of the fonts, just like you do it for the web browser. Even though it gave us a bigger font for CQL Console, unfortunately, it doesn't give us a bigger space to work with. I'm going to show you how to solve this problem later on, but for now, we will focus on the CQL Console here. As you can see here, we are connected to our cluster, and cluster name is CNDB. We don't have a choice to name this because it is controlled and provided as a service by DataStax. If you notice, CQL-SH version is 6.8.0 and Cassandra version is 4.0.06816. If you know DataStax Enterprise, DataStax has a format for their versioning, and you can see that clearly in this particular output. Let's describe our key spaces. As you can see here, there are some key spaces, but importantly, we requested to create a Astra underscore demo key space, and it exists here. Let us now just use the Astra demo key space. Let me describe tables to see if there are any tables in this key space. As you can see here, we have not created any tables yet. I will now create a simple table to demonstrate how to use the CQL console to create any new tables. I'm now going to create this simple My Friends table. As you can see, my table has been created. As you can see here, I have described my table, and this is the structure of my table. I'm now going to insert some data into My Friends table. As you can see here, I have inserted few rows into my table. So this is the basic usage of CQL console on the Astra DB portal. I'm back on my Astra DB homepage for sales organization. I'm going to click on this databases option here, and you can see we have one database called ORAMAD, and it is up and running, or the status is active. Since we created a key space and we created a table, inserted some data, you can see some reads and writes happening. I'm going to click on the database, and here on this page you can see obviously there are some reads and writes and some data transfer and storage consumption. Let us now talk about how applications will connect to Astra DB and what options do we have for that. I'm going to go to this Connect tab. So let's discuss about how applications will connect to the Astra DB. I'm going to review this methods available. So let's start with the APIs. As you can see here, we have three different APIs available under API section to connect to Astra DB. If you select the API and if you scroll through, this portal will help you with setting up all the required details on how to connect to Astra DB using the API you have selected. Let me go back to top of this page and switch to drivers section. Under drivers section, we have two options. One is cloud drivers and the second one is the native drivers. So let's talk about the cloud drivers first. You can see we have a couple of options here like using Rust API, Go, Node.js API or Java API. Using these drivers, we can connect to the Astra DB. Let us now review what is available under native drivers. You can see we have few options like Node.js, Python or Java driver options to connect to our Astra DB. And as I mentioned before, this portal gives you all the details you need to know on how to configure and set up your application connectivity. Let me select SDK option now. As you can see here, for software development kit or SDK, we have a couple of options using JavaScript SDK, Python SDK or Java SDK to connect to Astra DB. Let us look at integrations available for Astra DB. As you know, I always talk about this. Anybody who is using Apache Cassandra, I suggest they should also learn Apache Spark. And here is the Astra DB Apache Spark integration page. And you can read a lot about how to use Apache Spark for Astra DB. Let me go back to the drivers and show you that we have a native driver, Python Cassandra driver. Later in this course, we are going to talk about Python Cassandra driver, which we can use to connect to Astra DB. For now, we have completed a review of what are the options available for applications and application development to connect to Astra DB. Let us now take a look at DBeaver Community Edition and figure out how to use it for Astra DB. Note that DBeaver Community Edition is free and an open source product. DBeaver is a powerful and universal database tool or a graphical user interface to connect and work with several databases. DBeaver Community Edition is free multi-platform database tool for developers, database administrators, analysts, and all people who need to work with databases. DBeaver Community Edition supports all popular databases such as MySQL, Postgres, SQLite, Oracle, and many more databases. Unfortunately, out of the box, DBeaver Community Edition does not support Apache Cassandra or DataStax Astra DB. So let us now figure out how to use it with DataStax Astra DB. On the DBeaver web page, let's go to the download section. This is the download page for DBeaver. As you can see here, DBeaver Pro version, which is a paid version, supports Apache Cassandra, and notice Amazon Keyspaces is on this list. Amazon Keyspaces is a service offered by Amazon Web Services for Apache Cassandra. Since DBeaver Community Edition is free and open source, let us now download the Community Edition. If you are using Windows PC, then you have two options. We can download the Windows installer or we can download the zip version. I generally like to go with the zip version because you just download the packaged zip version, unzip the package, and you can start running the software. You don't need to install. Also notice that this version of DBeaver Community Edition was released only few days ago on December 26th, 2022. By clicking on this Windows zip link, I will download the DBeaver Community Edition. To configure DBeaver to connect to Apache Cassandra, we need to download a Simba JDBC driver. So for that, I am here on the DataStax website, and I will go scroll to the end of the page. I will now find Tools and Downloads. Under Drivers section, I will click on ODBC JDBC drivers. Under this list, I'm going to find Simba JDBC driver for Apache Cassandra. There are two versions available. I'm picking the JDBC 4.2, which is the latest version available for download. I'm going to click this checkbox and agree for all the terms and conditions. I will then click on this download button to download the software. As you can see here, I have already downloaded the DBeaver Community Edition and the Simba Cassandra JDBC driver. These two files are provided to us as zip files. I will now extract the software from these zip files. As you can see here, I have extracted the software. Let's run the DBeaver software now. After extracting the software under DBeaver Community Edition folder, I will find the dbeaver.exe file. I will now launch the DBeaver. So this is how the DBeaver Community Edition looks like. As I mentioned earlier, DBeaver Community Edition does not support Apache Cassandra out of the box. So now let us go ahead and configure our JDBC driver to allow connections to Apache Cassandra from DBeaver. First thing we need to do is to go to the database menu option and find the driver manager. This is the driver manager window. I'm now going to click on new option here. I will then go to libraries tab. I will add a file. As you can see here, this is the Simba Cassandra JDBC driver jar file we downloaded earlier from DataStax website. Next thing I have to do is click on this Find Class button. I also need to make sure I have highlighted the jar file before clicking on Find Class. If it is unable to find any classes, it's alright. What we need to do next is go to Settings, and we are going to fill in some information here. So first thing is driver name. I'm going to name it as Apache Cassandra. So remember that this configuration will work for Apache Cassandra open source or DataStax Enterprise, or we will use the same configuration for Astra DB. Driver type, I'm going to leave it as generic. Class name I have to type as com.simba.cassandra.jdbc42.driver. That's all we need to do on this screen. We can close this window by clicking on OK button. Now you can see we have added an entry called Apache Cassandra in the driver manager window. We can now close this window. So the next step to configure DBeaver for Astra DB is we need to download Astra DB Secure Connect bundle and tokens. I'm back on my Astra DB portal. Let's first go to our database. On the serverless databases homepage, I will click on the Connect button. Under the connection methods, I have selected drivers and native type. By default, Python is highlighted. To download a Secure Connect bundle, we just need to click on this Download Bundle option. It is asking me to select a region where our database is running. We have one region, but you can have multiple regions, and you will select a region to which you want to connect from your application. In this case, we are going to use DBeaver to connect. So I'm selecting US East 1, the region where my database is running, and it gives you few options here. You don't have to worry about anything, just click on the Download Secure Bundle now. After download is complete, we can close this window. Here is the secure bundle we have downloaded from the Astra DB portal. Next thing we need is a token which helps us to connect to our Astra DB. Let's go to the organization settings page. Let's go to the token management option. At this point, we have to select a role for which we are going to generate a token. You can read through all the available roles, but what we want to do is select a role which has very minimal access to the database, which can only do a read-write to the tables. I'm going to select read-write service account for this option. As you can see here, it has very limited privileges on the database. I will now click on a generate token option. Our token has been generated. So let me scroll down. And what you see here is the existing tokens are listed here. This is the default token created by Astra DB portal when we created our database, and you don't want to use this particular token. Now, this is the new token we have just generated right now. Here is the download token button to download this token. I have clicked on the download token option. Here is the token we have downloaded from the Astra DB portal. I will show you the contents in a little while. Now that we have downloaded the Secure Connect bundle from Astra DB portal and the token, I am back on the DBeaver now. Let's now create a new database connection. Here is the Apache Cassandra option we created earlier under Driver Manager. Let us click on Next. We need to provide a JDBC URL to connect to our Astra DB. Let's now work on the JDBC URL. This is the path where I have stored my Secure Connect bundle for Astra DB. Now the JDBC URL should look like this: jdbc://Cassandra:// Authentication mechanism 2 is for Astra DB. Then we have to provide tunable consistency. 6 is equal to local quorum. For the secure connection bundle path, I have to specify the same path where I have my secure bundle stored. Only big difference for the secure bundle path is we have to change these slashes to the other one. I'm going to copy this whole JDBC URL and paste it on DBeaver. So here you can see the complete JDBC URL to connect to our Astra DB. Next thing we need to talk about is the tokens we downloaded, that is the CSV file we downloaded from Astra DB portal. This is how the CSV file looks like. There are 4 values in here, or 4 columns in here: client ID, client secret, role, and token. We need to grab the client ID and the client secret. Imagine this is your username and password, but it is already pre-encrypted by Astra DB. As you can see here, the role column has read-write service account, the same role we used to create our token. Let me copy the client ID and paste it into DBeaver as username. Let's go get the password. I'm going to select the client secret without the double quotes, copy this whole string and paste it as password. So if you noticed, the username passwords are already encrypted by Astra DB portal. Let's go ahead and test the connection now. As you can see here, we are successfully able to connect to Astra DB from DBeaver. Let's go ahead and close this window and click on Finish. Here is the connection to the Astra DB. I'm just expanding these until we see our table. As you can see here, we are now connected to our Astra DB from DBeaver. Let's now run a query to check data in our table. Now on the SQL editor, make sure we have the Apache Cassandra connection selected here. Now let me run a simple select statement on our table. As you can see here, now we are able to fetch the data from a table stored in Astra DB. We have successfully made a connection to Astra DB from Community Edition of DBeaver. Remember, the similar settings will work for Apache Cassandra or DataStax Enterprise. This is my GitHub page. I have contributed a lot of small repositories and made them available for the community. We are going to use Python Cassandra driver, and I already made some programs to use with Python Cassandra driver. What we are going to do is we'll use Python Cassandra driver and connect from Python to Astra DB, and we will read and write some data. On my GitHub page, you can see all these repositories. Some of the interesting things here are I have published all my administration scripts for Apache Cassandra under this repository. I have published a Prometheus Grafana dashboard for Cassandra under this repository. I have completely documented how to use Cassandra's change data capture option and publish those changes to Apache Pulsar using this repository. I have documented everything we need to know about Python Cassandra driver in this repository. I've been publishing precompiled Spark Cassandra connector jars under this repository. Another very interesting project I worked on is how can we build our own private email server, and here is the repository for the private email server. So this is the Python Cassandra driver repository on my GitHub page. Please note that Python Cassandra driver is built by DataStax and distributed via this link. Python Cassandra driver is completely open source. I frequently verify and put that information here about what combinations of softwares are working properly. Earlier this year, I have updated all my Python programs to make sure they are all compatible with Astra DB. Also note that my Python programs on this repository are no longer compatible with Python version 2. What I'm going to do now is I will follow all the instructions from this particular repository, and we will configure our Python Cassandra driver. Later, we will also configure our Python programs to connect to Astra DB to read and write data. First, we will start with this instruction file, which contains how to install Python Cassandra driver when your server is able to connect to internet. In case you don't have access from your server to connect to internet, then you have to use this file. As you can see here, I have logged into my Returnal server as Cassandra user. As you can see here, on this server, we have Python version 3.9.14. Since we are going to clone a GitHub repository, we need this program called Git. If your server is missing this Git package, then you can install it as a root user using this dnf command. We need Python Cassandra driver to be able to connect from Python to Apache Cassandra or DataStax Enterprise, or in this case, we are going to use Astra DB as our database. Using this command, I will verify if Python Cassandra driver is already installed. As you can see here, Python Cassandra driver is not yet installed on this server. As you can see here, I have logged into my Returnal server as root user. Earlier, we used this command to check if Python Cassandra driver is installed on our server, but we did that using Cassandra user. Now, since I'm logged in as root user, let's verify this one more time. As you can see here, Python Cassandra driver is not installed on this particular server. We can use this pip install command to install Python Cassandra driver on our server. Note that if you run this command as a root user, then Python Cassandra driver program will become available for all users on this system. If you don't have root access on a server, then you can run this same command as a Cassandra user. In that case, only Cassandra user can use Python Cassandra driver. All other users have to install it for their own user. Also note that this will require internet connection from your server. This command will go to internet, download the package and install it. Let us now run this command. As you can see here, we have now successfully installed Python Cassandra driver on our server. Notice that I am back to Returnal server as Cassandra user. Let us verify if Python Cassandra driver has been installed properly. As you can see here, Python Cassandra driver is now available for Cassandra user, and it was installed as a root user and it was installed properly. If you notice, this Python Cassandra driver we are using is 3.25.0 version. This is the GitHub link for the Python Cassandra driver, and it is maintained by DataStax. Now it is time for us to clone this particular repository and start using it. To clone this repository, first we need to copy this particular URL. Now I am back on my Returnal server and logged in as Cassandra user. I will now create this folder and start cloning the GitHub repository into this folder. We can use git clone command to clone a repository from GitHub. I'm going to paste the GitHub repository link we copied earlier here. We can run this git command now, and it will go and clone the repository link we have provided. As you can see here, git clone was able to clone the Python Cassandra driver repository from my GitHub page. This is the exact copy of all the files which are published on the GitHub repository. First, let us start with this folder, which contains some simple demos on how to connect to the Cassandra or an Astra DB. As you can see here, this file contains some CQL commands. If you look at the contents of this CQL script, what it tells us is we need to create a new key space called cas demo. We also need to create this table and insert this sample data. Let us now go to the Astra DB portal and create this key space. I have now logged into my Astra DB portal. First, let us go to the database we created earlier. I will scroll down on this page and we will try to create a new key space. I will click on this Add Key Space option. We need to create this key space called cas demo. By clicking on Save, Astra DB will create the key space. If you notice, the status has changed to maintenance, meaning it is doing some background activity. There you go. In less than 1 minute, we got our key space created. Let us now use CQL Console to verify if we have any tables in this new key space. As you can see here, now we have an empty cas demo key space. I will now create this table. As you can see here, we have successfully created EMP table in the new key space on Astra DB. This is the table structure for EMP. As you can see here, we do not have any data in this table. Let us now use DBeaver to verify the same thing. I'm going to run a select statement on the EMP table. As you can see, EMP table is empty right now. I will insert these two rows into the EMP table using DBeaver. As you can see here, we were able to successfully insert two rows into our newly created cas demo key space EMP table using DBeaver connected to Astra DB. We have now completed setting up a demo table for our Python program. Now let us look at the CAS Connection Manager Python program. If we are running our Cassandra on an on-prem server or we are running DataStax Enterprise, then we have to provide our username passwords to connect to the database over here. Since we are using Astra DB, this is where we have to change our Astra DB related settings. If you remember, to configure our DBeaver, we were able to get a secure connection bundle and also the credentials required under token management from the Astra DB portal. On this server, I have already downloaded the Secure Connect bundle required to connect to the Astra DB, and I have also downloaded the token file. As you can see here, these are the credentials we need to connect to our Astra DB. At this point, we know where our secure bundle is stored on this server. I'm going to now paste the full path to the Secure Connect bundle we have downloaded earlier. If you remember, we already downloaded the token information and the client ID needs to be pasted here. We also got the client secret when we downloaded the token. I will paste it now. Just in case, if you have decided to name your CAS demo key space something else, then you have to provide that here. We do not have to do any more changes in this file, so I'm going to save this file. Let us now modify the global settings.python program. If you notice, we have a parameter here which says use Astra DB equal to false. We have to make it use Astra DB equal to true. As you can see here, I have modified this parameter which is use Astra DB equal to true. Let me save this file. Now it is time to execute our first Python program which goes and connects to our Astra DB and fetches some information. Let us now run the get cas cluster info.python program. As you can see here, now we have successfully connected to our Astra DB. As you can see here, this cluster contains 9 nodes. If we have configured everything properly, we should be able to successfully connect from our Python program to Astra DB. If you get any other errors, then we have to take a deep look at what is going wrong. Let us now run this read-write cas emp.python program. What it does is it inserts one new row into the emp table, as well as it reads some data and prints them on the screen. If you know Python, then you can go ahead and look at the Python code to understand what it is doing and how the code is written. Let us now go back to the DBeaver and verify that we have a new row in the EMP table. As you can see here, this is the new row inserted by the Python program which is running on our local Linux box, but it is connecting to the Astra DB and inserting data over there. You can try running this program another 5 times and see if the new data is going into the Astra DB or not. As you can see here, our Python program has automatically generated some random data, but it was inserted into Astra DB. Under simple demos, we have only 2 Python programs and we have executed both of them. Let us now go look at what else is available under this repository. Let us now go ahead and verify what is this sales application which can generate sales automatically. As you can see here, we have 2 familiar files. First, we have to modify CAS Connection Manager to provide the path for our Secure Connect bundle, and also we have to provide tokens so that we can connect to our Astra DB. Also, under Global Settings Python program, we have to change it to Use Astra DB. Also remember to check out these 3 files we have for large system or a medium system or a small system. By default, global settings are provided for a small system. Let us now modify the CAS Connection Manager and specify all the parameters required for connecting to Astra DB. As you can see here, I have provided the full path to the Secure Connect bundle we have downloaded earlier. I have also provided the client ID and client secret tokens over here. If you notice, it is looking at a new key space. Looks like we have to create this. After a few steps, I will verify on this key space. Let me close this file. I will now modify the global settings file. Let us change this parameter use Astra DB equal to true. Also notice that this global settings file has some settings for the small system. Total users equal to 1000, total products equal to 5000, generate maximum orders equal to 12, generate max products under each order is 6. You can tweak these settings to increase the amount of data we generate or to decrease the amount of data we generate. I will save this file now. As you can see here, we have three CQL scripts. Let's start with the first one. In this case, we have to create a new key space called sales. I'm back on my Astra DB portal. Let's go to the database and add a new key space. As you can see here, database status has changed to maintenance again. In less than 1 minute, we have our key space added. Let us now look at the second file. As you can see here, the second script contains several create table commands. I will now copy paste the content of this file onto our CQL console. We have now successfully created all the required tables in this key space. Let us now take a look at the third CQL script. This contains a bunch of initial data which we need to insert into the lookup tables. I will now copy paste all these insert statements into our CQL console on Astra DB portal. Let us now verify if our data is successfully saved on Astra DB using DBeaver. As you can see here, this is the new key space we have created, and we have also created all these tables using the scripts provided from the GitHub repository. This is one of the lookup tables in the sales key space. As you can see here, we have inserted data using the CQL script provided by the GitHub repository. According to GitHub repository, the next step is to create some users on this system. If you look at the users table, we do not have any data right now. Let's go ahead and use Python program to generate some users. As you can see here, we have to use this Python program to generate some users. Let us now run generate users Python program. Good, we are able to generate about 1000 users on this system. It is time to verify if our users got generated. Let's use DBeaver for that. As you can see here, our Python program was successfully able to generate some users on the sales key space. Now that we have some users, let us now generate some products which can be sold to these users. Before we run this command, I want to check if the products table has any data or not. As you can see here, the products table under sales key space has no data right now. Let us now go ahead and run the Python program to generate some products. While this program is running, we can use DBeaver to select some rows from the table to see if it is generating any data. As you can see here, now we are able to see some data in the products table. As you can see here, our Python program has successfully generated 5,000 products. Now that we have generated some users and products using these Python programs, let us look at how to generate some orders. First, let us verify what data is available in the orders tables. We have two tables for sales orders. So let us verify the sales orders table. As you can see here, sales orders table is empty. Let's now check sales order products table. And now we know both of our sales orders and sales order products tables are empty. Now we can use our Python program to generate some sales. Using this Python program, we'll be able to generate some orders. As you can see here, we were able to successfully generate 9 orders. Let us now look at the data which is existing in the Astra DB using DBeaver. These are the few orders which were generated very recently. As you can see here, now we know that the sales order products table also contains some data. All this data was automatically generated by the sales Python application. If you want to keep generating sales data automatically, now we can put this program in a cron tab. Using this command, we can verify if our cron tab exists. As you can see here, currently we do not have any entries in the cron tab. Let us now modify the cron tab. As you can see here, I have added one entry into the cron tab. Now, cron tab will run this Python program every 2 minutes and the output will be going into this log file. We have now successfully automated generating sales data using cron tab. As you can see here, now we have a log file. That means cron tab has executed the Python program and it must have generated some orders. Let us just tail this log file for some time. Looks like crontab is running our Python program every 2 minutes. We will watch this log file for some more time. As you can see here, in the past 1 hour, this Python program has generated more than 200 orders. I hope you like my Python sales generator. Please use this Python sales generator on DataStax Astra DB and also check out with on-prem Apache Cassandra. Also, please don't forget to check other repositories I have published on my GitHub. And do not forget to give me a star for each of these projects. As you can see here, I am back on my Astra DB portal. Let us now discuss about the database health and look at some of the Grafana metrics. I will click on this link for databases. As you can see here, we have only one database right now, and we have started generating quite a bit of reads and writes. You can see this database has consumed this much storage, and also we have generated this much of data transfer. This database is currently active. If we had more databases under sales organization, then they will all show up here, and you can see the summary metrics over here. Let me click on the database link to go to the database homepage. Since we have been generating sales using Python code, you can see here my read requests and write requests have increased. Also, storage consumed and data transfer rates have increased. Let us now quickly take a look at how Astra DB has integrated Grafana charts. I will click on this Health tab. I will collapse the left side menu. As you can see here, Grafana charts has been nicely integrated into Astra DB portal. You can see all the read and write requests show up on this graph. In last 30 minutes, we don't have any request errors, which is good. This is the chart displaying the write latency. Most write latency is less than 2 milliseconds, which is a very good response. This is the chart showing write size distribution. This is the read latency related chart. This is the range latency chart. Currently, I am not using any lightweight transactions. If I used any lightweight transactions, those metrics will show up on these charts. All the tombstone related charts are under this category. Also, we can change the time range for which we can see these reports. Over here, we have an option to either switch off the auto refresh or we can change the refresh interval. As you can see, Astra DB team has done a wonderful job in integrating Grafana charts into the Astra DB portal. I have logged back into the Astra DB portal. As you can see here, I have not used my Astra database for longer than 48 hours. Notice that whenever we don't use our database for more than 48 hours, it goes into a hibernated state. On the serverless databases dashboard, we have an option to resume the database which is in a hibernated state. I will now resume this database. As you can see here, the database status has changed to resuming. My database became active. So remember that when you do not use Astra database for longer than 48 hours, it will be automatically put in a hibernated state. And it is very easy to resume the database from hibernated state. Let us now talk about a new tool called Astra CLI, Astra Command Line Interface. This is the Astra CLI's GitHub page. Astra CLI is 100% developed in Java and it was developed by Cedric. This is the documentation page for Astra CLI. As you can see here, I have logged back as Cassandra user on Returnal server. This is my Linux virtual machine where I can install Astra CLI and connect to Astra DB. Using this command, we can install Astra CLI. You can find this install command on the Astra CLI documentation page. Remember that your Linux machine will require an internet connection to download the software. Let us now go ahead and run this command. As you can see here, Astra CLI tool has been installed. Always remember that after installing Astra CLI, we have to exit from the current SSH session and start a new session. I have now reconnected to my Returnal server as Cassandra user. Also note that to install Astra CLI, I was just using Cassandra user. We do not require root privileges. So now that we have Astra CLI installed, the first step we have to do is to configure it. We have to run Astra setup command to configure the Astra CLI. As you can see here, it is asking us to provide the Astra token. Let's go back to the Astra DB portal and talk about these tokens one more time. As you can see here, I am back on the Astra DB portal. I will go to the settings. I will now go to the token management. Remember that Astra CLI is a very powerful tool. Let us now create a new token which can be used with Astra CLI. For Astra CLI, I'm going to create a token with the administrator user role. Remember that this is dangerous if it falls into a wrong hands. I will select the administrator user for role. As you can see here, administrator user role is very powerful and it can do lot of damage if it falls into the wrong hands. I will now generate a token for the administrator user role. Our token has been generated. One very important note here is you have to download these token details and carefully save the downloaded file. Right now, Astra DB portal will not allow you to re-download a previously generated token. If you remember previously, to configure our DBeaver, we downloaded the token details and we used the client ID and client secret. Interestingly, for Astra CLI, we just need this token information. I don't want to even download this token details. I will just click on this button and copy the token information. I am back to the Astra CLI setup options. I have copied the Astra token information from Astra DB portal. I will paste it here now. I will just hit an enter key. As you can see here, Astra CLI configuration has been saved. Let's go ahead and start using Astra CLI. Here is the command to check the version of Astra CLI. We can get Astra CLI help using this command. As you can see here, I have executed Astra config list command. There are a couple of output options we should talk about. Most of the Astra CLI commands have this output option. So first let's look at what is output human option. As you can see here, this is the default output when we ask for output human. The second output option we have is the JSON. As you can see here, now the output is a JSON document. There is one more option we can use is the comma separated values for the output. It doesn't have too much information, but there is a CSV format available. All these options are very useful when we want the output passed to another program or a script. Let's go ahead and look at some more commands. The next command we are going to use and work with is the organization details. As you can see here, for Astra DB portal, we have created sales organization. It is possible to just get organization name using this command. Let's now use the output option of comma separated values with Astra org command. As you can see here, the output is presented as a comma separated values. Let us now get some database details from Astra DB using Astra CLI. First, let me list all the databases on our Astra DB. As you can see here, I have only one database named as Oramad. This database is in active status, and this database default region is US East 1. You can use Astra DB list regions command with a database name, and it will return all the details we need to know about which cloud provider this database is using, how many regions are under that cloud provider, and by default nowadays Astra DB is serverless. Using the Astra DB status command, we can verify the database status. As you can see here, database Oramad is in an active state. Let us now list out all the key spaces present in Oramad database. These are the three key spaces we created earlier on this database. Using Astra DB CQL sh command, we can actually run CQL commands from Astra CLI. When we run the Astra DB CQL sh command for the first time, it will go ahead and download the CQL shell module. As you can see here, we have only one table in the CAS demo key space. Using this command, I want to list out all the tables in the Astra demo key space. Again, we have only one table in the Astra demo key space. As you can see here, I have executed a CQL command using the Astra CLI. As you can see here, I will try to insert a new row into the table using Astra CLI. I did not get any errors. So let's check if the new row got created on the Astra DB. This is the new row which got inserted into the table. Now that we have tried few basic commands using Astra CLI, let's go ahead and see if we can create a new key space on Astra DB using Astra CLI. Using this Astra DB create keyspace command, By passing a keyspace name, we can create a new keyspace. Remember that this command will require additional privileges. If you have created only a read-write role, then it will not have the create keyspace privilege. That's the reason I have created the administrator user role for the Astra CLI token. All good. We have now created a new key space on our Astra DB. Let us now go one step further. With this command, we can create a new database on Astra DB with a key space called HR_info. Okay, after a few minutes, we have our new database created on Astra DB. Here is the new Astra database we have just created, which is running on US East 1 on the Google Cloud Provider, and the status is active. Imagine you have some CQL scripts on your system and you want to run them against Astra DB. Here is a simple example. In this script, I am creating a new table and inserting some data. Let us now talk about how to run the script against Astra DB using Astra CLI. First thing I want to check if my DB's table is already existing in Astra demo keyspace. As you can see here, my DB's table is not existing in Astra demo keyspace. Using this file option, we can run the CQL script on a Astra DB using Astra CLI. Okay, it has completed executing the script against Astra DB. As you can see here, now MyDB's table is existing in Astra demo keyspace. We executed few of these commands earlier. Now I'm running a select statement against the new table we created, because using that CQL script we executed, we also inserted some data. Okay, we were able to successfully run the CQL script, create a new table, and insert some data using the CQL script via Astra CLI. Astra CLI is a very new tool, but it has already become very powerful. And I'm sure in future Astra CLI will evolve a lot and it will become our best buddy for using it with Astra DB. I'm back on my Astra DB portal. Here is the HR database which we created using Astra CLI. I want to show you how to drop this database or terminate this database. Hopefully you will never have to do this in production. We'll go to the settings for HR database. I will scroll through the page and go to the end of this page. And here is the terminate database option. As you can see here, when we want to terminate our database or we are dropping the database, it is asking for an extra confirmation to provide the database name. As you can see here, database must match with what we are dropping. I have intentionally provided a wrong database name and it doesn't allow me to drop it. Now I have provided the correct database name and it has enabled the terminate database button. I will now click on this terminate database button and drop the database. As you can see here, HR underscore database, which we created using Astra CLI, is now terminating. Finally, after some time, our HR database has been dropped. Let us now talk about change data capture for Astra DB and Astra streaming services. We can enable change data capture option for Astra DB, which will track all the changes done to the tables or the data inside the tables. Those changes can be easily streamed to Astra streaming platform. Astra streaming is based on Apache Pulsar. On my GitHub page, you can refer to this repository which shows a lot of detail about how CDC works when you want to publish these changes to Apache Pulsar. With Astra DB and Astra Streaming, this whole process is very easy. Let's take a look at that right now. I'm going to quickly show you a very small demo of how to configure Astra Streaming and publish the change data capture to Astra Streaming. As you can see here, I'm back on my Astra DB portal. I will first click on this streaming option. I will first create a new stream. As you can see here, we have to provide the tenant name and select a cloud provider. As you can see here, to create a new stream, I have selected the tenant name as sales-data. I have also selected US East 1 under Google Cloud for running this service. Note that Astra Streaming is not free. It is a pay-as-you-go model. I will now click on this Create Tenant button. Our first tenant has been created. Let us now head back to the database homepage. I will go to the CDC tab. I will click on Enable Change Data Capture. I will select a tenant which was already pre-created. I will select a key space And here I have to provide a table name for which we want to capture the data changes. I have provided sales underscore orders table to track for the change data capture. I will now enable CDC for this table. By going back to enable CDC option, I can add another table and monitor the data changes. Now I have two tables added to change data capture. As you can see here, status for the sales orders table has become running, whereas CDC for products table is still initializing. I will now click on the sales underscore orders table to see the details. As you can see here, data started flowing between CDC and Astra Streaming. Change data capture for Astra DB when combined with Astra Streaming is very useful for the business. Unfortunately, we have come to the end of this course. I hope this was a wonderful journey for you. We discussed about the importance of DataStax in the Cassandra community. We discussed about why Astra DB is a very important technology for Cassandra community. We were able to register for Astra DB without paying any money or providing any credit card information. We discussed about enabling and disabling the new user interface. We discussed about organizations. We discussed about how to get help and look at the documentation for Astra DB. We created a new database on Astra DB. Using CQL Console on Astra DB portal, we were able to interact with our Astra database. We discussed about the options available for applications to connect to Astra DB. We saw how to use DBeaver Community Edition to connect to Astra DB. Using Python Cassandra driver from Linux servers, we were able to connect to Astra DB, and we also saw how to generate some sales data. We reviewed the Grafana integration for Astra DB. We resumed a hibernated Astra database, and also we saw how to terminate a database. We used Astra CLI, Astra command line interface, to interact with Astra database. We discussed about change data capture and Astra streaming services. On the Astra DB portal, do not forget to check out integrations. I also highly suggest you check out the sample app gallery or sample applications available on the Astra DB portal. Just like me, hope you also love Astra DB now. Please contact me and let me know what are the use cases you want to run on Astra DB. Thank you.